The process location is an important parameter that should be monitored. In this lesson, you will learn how to create a control chart for the process location parameter median. And hello again to this lesson, which essentially has 3 learning objectives. First of all, of course, you should be able to name the main basics of a median chart. Second, you should be able to calculate the medians of the samples, the process location, and the standard deviation on the basis of samples. And finally, of course, you should be able to calculate the warning and control limits of a median chart. This lesson is divided into 3 chapters. In the first chapter, we get an overview of the different mean values and the essential elements of a control chart for medians. In the second chapter, the process location and the spread of the process are calculated on the basis of the data from a pre-series. And in the last chapter, the actual control chart is created and the warning and control limits are calculated. To be able to classify the median control chart in comparison to the other quality control charts, this picture shows the connection between the various characteristics and the control charts used. The different characteristics are shown on the left and the different control charts on the right. The quantitative characteristics, shown on the left, can be divided into 2 different categories. First, the variable characteristics. These are all characteristics that can be measured. They always have a value and a unit. Examples of this would be the length, hardness, weight, surface roughness, or tensile strength of a component. Second, there are the attributive characteristics. Those are all characteristics one can only count. But we don't want to go into detail about them here. On the right, we have the different control charts for variable characteristics with a white background. These are also called Shewhart charts, named after American Walter Andrew Shewhart. As you can see, there are 3 control charts for monitoring the process location and 2 control charts for monitoring the spread. The median chart is one of the location charts. Let's start with the basics of the median chart. When we talk about the median, we mean the value in the middle of the values ordered by size. The probably most well-known average value is shown in the middle. The arithmetic mean is the sum of all values divided by their number. The mode value is then shown on the far right. The mode is the most frequently occurring value. The limits for a control chart for the median are calculated differently than for the arithmetic mean, hence this distinction here. As a practical example, we take this tried and tested piston again. The product characteristic to be monitored is the nominal diameter of 60.1 mm. As you may already know from the control charts for individual values, the main parameters of the control chart are also shown here in the header. Only the y-axis scaling here is for the medians. In the lower part, the median was calculated for each random sample and entered in the table. The warning limits are calculated such that there is a 95% probability that the median of a sample falls between these limits. The control limits are calculated in such a way that this probability is 99%. Let's briefly review the meaning of the symbols in the formulas. Mu is the population mean and mu hat is the median of a sample, which is used to estimate the true median of the population. Sigma is the standard deviation and sigma hat is the sample standard deviation. AC and AW are factors for calculating the warning and control limits. How to calculate these factors yourself is explained in a separate lesson. The required quantile of the standard normal distribution is also the subject of another lesson. The factor Cn is taken from tables. To calculate the limits, the process location μ and the standard deviation sigma of the population must be known. Since these are usually not known, they must be estimated as best as possible using a random sample. This random sample can be taken from an ongoing series production or from a pre-series carried out specifically for this purpose. In this chapter, let's take a look at the results of such a pre-series and use the measurement results to calculate the median and the standard deviation of the process. Several random samples were taken and the diameter of each part measured and the measurement results entered in the table. Then the median was calculated for a sample size of 5 and entered in the control chart. This resulted in the value curve shown here. When calculating the warning and control limits, it is assumed that the values are approximately normally distributed. A visualization in the histogram and the envelope curve above it should be sufficient proof of this at this point. The median was calculated from 5 individual values and written in the right-hand column. The mean value was then calculated from these medians, so the mean of the medians. This value is called the grand mean, recognizable in the symbol by the wave and straight line above the x. This has a value of 60.104 mm. Now the standard deviation has to be calculated on the basis of the same measured values. This can be done, for example, with MS Excel and the function stdev.s. However, there are other methods that can be used to estimate the standard deviation. The standard deviation of the 50 samples is 0.022 mm. And with that, we have everything we need to calculate the warning and control limits. The mean μ is 60.104 mm and the standard deviation is 0.02 mm. Both values were transferred to the header of the control chart. In this part, we now come to the calculation of the 95% warning limits and the 99% control limits. First, only the two formulas for calculating the upper warning and control limits are shown on the left-hand side, where μ is the mean of the medians and sigma is the standard deviation of the entire sample, which we calculated in the previous chapter. The only unknowns are the factors AC, AW and CN. These must be taken from tables. The table on the left shows some example values for different sample sizes and the non-interference probabilities of 95 and 99%. The factors AC, AW and CN depend on the sample size. AC and AW also from the non-interference probabilities. How to calculate these factors yourself will be explained in a separate lesson. For a sample size of 5, we take from the table the value 0.877 for AW and 1.152 for AC. For CN, the value is 1.197. The values for AC times CN and AW times CN were also entered in the header of the control chart. For the further calculation, the table on the left has been expanded to include the formulas for the lower warning and control limits. If we now enter the values in the formula and calculate the upper control limit, the result for UCL is 60.13 mm. This upper control limit has already been drawn on the control chart. A value of 60.125 is calculated in the same way for the upper warning limit. This limit was also drawn on the control chart. A value of 60.083 mm then results for the lower warning limit and a value of 60.076 mm for the lower control limit. Both limits can also be found in the control chart. Now, what do these limits mean? For the warning limits, this means that there is a 95% probability that the median, calculated in each case, will be within these limits. And with a 99% probability, the median will lie between the control limits. This means that the probability that a median is outside the control limits is less than 1%. If such an improbable event occurs, this is an indication that the process might be no longer under control. The reason for this limit violation must be found and, if necessary, the process must be readjusted. Well, that was a lot of new information. Therefore, I would like to conclude by repeating the 4 most important key messages. The median is the value separating the higher half from the lower half of a set of values. The median is a measure of the process location. The non-interference probability for the control limits is 99%. And if a value is outside the control limits, the process must be readjusted. If you found this lesson helpful, please let me know and leave a comment. Thank you for that, take care and see you next time. Bye.